Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today on relations, mapping and functions. In this video, we are going to consider relations. In the subsequent videos, we will consider mapping and functions. Now let's begin with relations. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to differentiate between a relation, a mapping, and a function. You should be able to find the rule of a mapping. You should be able to find the range of a function when the domain is given. Don't worry if you don't understand these terms, you understand as the lesson goes on. And you should be able to find the value or values that makes a function undefined. So at the end of this topic, you should be able to achieve these four main basic objectives. Now, let's begin with our topic of the day, relations. Let's consider the following statements. Statement 1. Amma is the sister of Kofi. Statement 2. Kojo is the son of Mr. Danso. And statement 3. Equia is the daughter of Mrs. Kwarting. Now we can see from here that in each of these statements, we can see a relation or a relationship. Amma is Kofi's sister. Kojo is the son of Mr. Danso. Equia is the daughter of Mrs. Kwarting. So we can say Amma is related to Kofi. Kojo is related to Mr. Danso and Equia is related to Mrs. Kwarting. Now in each case, we can see in the first instance that Amma is a separate human being on her own. So is Kofi. Now Kofi is being linked to Amma by the statement is the sister of. The statement is the sister of gives us an indication that Kofi is related to Amma. In the same case, the link between Kojo and Mr. Danso was seen because the statement is the son of gives us an indication that Kojo is related to Mr. Danso. The same applies to Equia and Mrs. Kwarting because Equia is the daughter of Mrs. Kwarting. So in the first instance, Amma is being linked to Kofi by the statement is the sister of. In the second instance, Kojo is being linked to Mr. Danso by the statement is the son of. And in the third instance, Equia is being linked to Mrs. Kwarting by the statement is the daughter of. These are relations or relationships that we see in everyday life. These things also happens in mathematics. Sometimes we may have a set, two sets. Now these two sets can be linked by a statement. The statement can be in form of words or a mathematical expression. Now when you have two sets and they can be linked by a statement, the statement linking those two sets is what we refer to as a relation. So in this case, Amma is linked to Kofi by the statement is the sister of. So the statement is the sister of is the relation in the first instance. In the second instance, Kojo is linked to Mr. Danso by the statement is the son of. So the statement is the son of is the relation. In the third instance, Equia is being linked to Mrs. Kwarting by the statement is the daughter of. So the statement is the daughter of is the relation. Just as we can see this in everyday life, the same thing also happens in mathematics. So when a statement can link two sets, we call that statement a relation. So just as we said, a relation is a connection between two sets. A relation associates elements of one set to the elements of another set. Let's take an example. Let's take the set A. In the set A, we have the cities Kumasi, Accra, Sunyani, and Tamale. In the set B, we have the regions Greater Accra region, Northern region, Brong Ahafo region, and Ashanti region. Now we can see that these are capital cities and these are regions, and we can link capital cities to the regions. So Kumasi can be linked to Ashanti region, Accra can be linked to Greater Accra region, Tamale can be linked to Northern region, and Sunyani can be linked to Brong Ahafo region. So the statement linking these two sets is what we refer to as the relation. So in this instance, we see that the relation is the capital of. So the relation in this instance is the statement is the capital of. Now let's try and see if this can work. So we are saying that the statement is the capital of is linking members of set A to members of set B. So let's take the first member of set A. So we can say that Kumasi, then we pick the relation, is the capital of, then we pick the image here, so Ashanti region. So we say that Kumasi is the capital of Ashanti region. The same applies to Accra is the capital of Greater Accra region. Sunyani is the capital of Brong Ahafo region, and Tamale is the capital of Northern region. So the statement is the capital of is linking members of set A to members of set B. When this happens, we say that the relation is the capital of. So the relation in this case is the statement is the capital of. Now let's go ahead and learn some terms about relations. When you have a relation like this, we say that the set of cities in A is called the domain of the relation. Now let's look at the direction of the arrow. You see it moves from left to right. So it's moving this way, and because it's moving this way, we see that members here, members that are at this side of the arrow, we refer to them as the domain. The members that are here are referred to as codomain. So members in set A here are referred to as domain, and members in set B here are referred to as the codomain. Remember, you can always find the domain and the codomain looking at the direction of the arrow. So the arrow moves from here to here, so it moves in this direction. When it moves in this direction, then those on the left side are called the domain, then those on the other side or the right side are called the codomain. So we've now known what a domain is and what a codomain is. Let's move on and learn some more terms about relations. If an element, say X, of the domain is related to an element, say Y, of the codomain, then Y is the image of X under the given relation. Now what does this mean? I'm going to pick an example to explain this. So we can see from here that we have seen in the previous slide that Kumasi can be linked to Ashanti region. Accra can be linked to Greater Accra region. Sunyani can be linked to Brong Ahafo region, and Tamale can be linked to Northern region. Now we know for sure that Kumasi is related to Ashanti region. That's why he's saying that if an element X of the domain, so in this case, let's assume that X is Kumasi, is related to an element Y of the codomain. Kumasi is related to Ashanti region, so let's say that Y is Ashanti region. Then Y is the image of X. So what it means is that if Kumasi in the domain is related to Ashanti region in the codomain, then we say that Ashanti region is the image of Kumasi under the relation. I hope it's clear. Kumasi is in the domain, Ashanti region is in the codomain. Kumasi is related to Ashanti region. So we say that Ashanti region is the image of Kumasi under the relation. Don't forget that the relation in this case here is the capital of. So under the relation is the capital of, we say that Ashanti region is the image of Kumasi, because Kumasi is in the domain and Ashanti region is in the codomain, and they are being connected. In that same way, we can say that Brong Ahafo region is the image of Sunyani under the relation. Northern region is the image of Tamale under the relation, and Greater Accra region is the image of Accra under the relation. Let's take another example. We can see from here that 2 is linked to 4, 4 is linked to 16, 5 is linked to 25, 6 is linked to 36. Now from here, we can say that 4 is the image of 2 under the relation. 16 is the image of 4. Sorry. 25 is the image of 5. And 36 is the image of 6 under the relation. So members here are what we refer to as the domain, and those here are what we refer to as the codomain. Let's take another example. Let's say in this case 26 is linked to 52, 7 is linked to 14, 4 is linked to 8, and 18 is linked to 36. So we can say that 14 is the image of 7, 52 is the image of 26, 36 is the image of 18, and 8 is the image of 4. Once again, those here are what you refer to as the domain. This set is referred to as the domain, and this set is also referred to as the codomain. Now let's learn another very important thing in relations: the range. The range is the set of all possible images of the domain, and the set of all possible images of the domain is what we refer to as the range. So when you come here, you can see that all these here are possible images. These are what you refer to as the images. All of them, if you take them one by one, so 8, 14, 36, and 52, all of them in one set is what you refer to as the range. So if you take 8, 14, 36, and 52 in this case, we say that you have the range, the set of all possible images. The set of possible images that the domain can produce is what we refer to as the range. In the same way, in this example, 4, 16, 25, and 36 is what we refer to as the range, the set of all possible images. In this example, Greater Accra region, Northern region, Brong-Ahafo region, and Asante region is what we refer to as the range. So the range is the set of all possible images that the domain can produce. Let's move ahead and look at some types of relations. We are going to consider the first type, called the one-to-one relation. In this relation, each member of the domain has only one image in the codomain, and each element in the codomain has only one element in the domain. That is clear, right? So in one-to-one relation, each member here in the domain has only one image in the codomain. You now understand what a domain is, what a codomain is, and what an image is. So these are members of the domain, and these are members of the codomain or the range. So we say that in one-to-one relation, each member in the domain has only one image in the codomain. So you can see from here that 2 has the image 4, 4 has the image 16, 5 has the image 25, and 6 has the image 36. Now, it doesn't end there. Each member in the codomain has only one element in the domain. So when you come here, 4 is also having only 2 here. 16 is related to only 4, 25 is related to only 5, and 36 is related to only 6. So it's one-to-one, one-to-one. Each member in the domain maps on to only one member in the codomain, and each member in the codomain relates to only one member in the domain. So when that happens, we say that we have a one-to-one relation. So in this case, you can see that the relation is the square of, so you look at this, 2 is the square of 4, so that is the relation. 4 is the square of 16, 5 is the square of 25, and 6 is the square of 36. So that is the relation in this case. So this is an example of a one-to-one relation. Let's look at another example. So when you come here, you see that 26 goes on to 52, 7 goes on to 14, 4 is related to 8, and 18 is related to 36. In the same way, 14 is related to only 7, 36 is related to only 18, 52 is related to only 26 and 8 is related to only 4. So whenever you have this, you say that you have a 1-to-1 relation. And in this example, the relation is half of, because you can see from here that 26 is half of 52, 7 is half of 14, 4 is half of 8, and 18 is half of 32. So the relation here is half of. Let's look at another type of relation, one-to-many. In this relation, one element in the domain has several images in the codomain. So in the previous example, we saw in the previous type, we saw one-to-one. This is one-to-many. So in one-to-many, you can see that one element in the domain has several images. When we say several here, several is 2 or above. So if it's more than 1, it's considered as several. So it has several images in the codomain. So in this example, 2 has the images 4, 6, and 8. 5 has the images 15 and 25. So unlike the previous one where 2 had only one image, in this case 2 is having more than one image. So we see that it is one-to-many. One in the domain maps onto many in the codomain. Let's look at the next one. So in this case, the relation is a factor of. So we can see that 2 is a factor of 4, 2 is a factor of 6, 2 is a factor of 8. In that same way, 5 is a factor of 15 and 5 is a factor of 25. So the relation here is a factor of. Let's look at the next type. We have many to one. So we've considered one to one, we've considered one to many. We are now going to consider many to one. In many to one relation, several elements in the domain have one image in the codomain. Now let's look at an example. So you can see from this example that 4, 6, 8, and 12, which are all in the domain, they all have only one element in the codomain. So 4, 6, 8, and 12, all of them are related to only one element, which is 2. 15 and 25 are related to only one element, which is 5. So when this happens, we see that we have many to one. Many in the codomain mapping related to only one element in the domain. I hope that is clear. Many in the domain relating to only one element in the codomain. So many in the domain relating to only one element in the codomain. So we have 4, 6, 8, and 12 relating to only 2 in the codomain. We have 15 and 25 relating to only 5 in the codomain. So when this happens, we say that we have many to one relation. Try and see if you can find the relation here. The relation is a multiple of. So you can see that 4, 6, 8, and 12 are all multiples of 2. 15 and 25 are all multiples of 5. So in this case, the relation here is a multiple of. Somebody can also say the relation is greater than, because when you come here, you can see that 4, 6, 8, and 12 are greater than 2. 15 and 25 are also greater than 5. So here we choose to go with is a multiple of, because it gives a better description of the relation that we have here. Let's look at the last type of relation that we are going to consider. We've considered one to one, we've considered one to many, we've considered many to one. Lastly, we are going to consider many to many. In this relation, several elements in the domain have many elements in the codomain, and several elements in the codomain have many elements in the domain. What does this mean? Let's pick an example and see what this means. In this example, we can see that we have 2 and 3 in the domain. We have 12, 24, and 30 in the codomain. Now let's look at this. It says that several elements in the domain. Remember, when we say several here, we mean more than one. So here we have 2 here, so it qualifies as several. Now these several elements, 2 and 3, they have many elements in the codomain. So when you see here, you can see from here that 2 and 3 are all related to 12. At the same time, 2 and 3 are all related to 24. At the same time, 2 and 3 are all related to 30. So we have many in here. 2 qualifies as many. We have many relating to many. We have many in the domain relating to many in the codomain. In the same way, we are saying that several elements in the codomain have many elements in the domain. In the same way, 12 here, 12 and 24, which also qualifies as many, is related to 2. The same time, 12 and 24 are also related to 3. At the same time, 24 and 30 are related to 3. 24 and 30 are also related to 2. 12 and 30 are related to 3. 12 and 30 are also related to 2. So we have many in the domain relating to many in the codomain, then many in the codomain relating to many in the domain. So when this happens, we see that you have a many to many relation. So in this case, the relation is a factor of. So you can see that 2 and 3 are factors of 12. At the same time, they are factors of 24. At the same time, they are factors of 30. Thank you for watching this video on relations. I hope you understood everything that was explained here. If you have any problem, interact with me on our social media handles and I'll help you to understand. In the next video, we are going to look at mapping and we will see how to find the rule of a mapping. Bye-bye. We are on the topic relations, mapping, and functions. In the previous video, we looked at relations. In this video, we are going to look at mapping. So what is a mapping? A mapping is a relation in which each member in the domain maps onto only one member in the codomain. Based on this definition, we can say that one-to-one relation and many-to-one relations are mappings. In the previous video, we looked at what a domain and a codomain is. From that video, we saw that if you have a one-to-one relation, one element in the domain maps onto only one element in the codomain. So it satisfies the definition of a mapping because it says that each member in the domain must map onto only one member in the codomain. In the same way, if you have a many-to-one relation, each member in the domain maps onto only one member in the codomain. So here 4 has only one image, which is 2. 6 has only one image, which is 2. 8 has only one image, which is 2. And 12 has only one image, which is 2. 15 has one image, which is 5. And 25 also has only one image, which is 5. So all these two are examples of what we call a mapping. In the previous video on relations, we saw that relations, when you have two sets, they can be linked by a word statement, and that word statement is what we refer to as the relation. The connection between the two sets is what we refer to as a relation. On mapping, in mapping 2, members of the two sets can be linked by a mathematical statement. In this case, it's not going to be a word statement, but it's going to be a mathematical statement, and that statement is referred to as the rule or the formula. In this lesson, we are going to consider two types of mapping. We are going to consider the linear mapping and the exponential mapping. So when you have these mappings, you are going to see how to find the statement that is linking them, or how to find the rule or the formula that is linking the members of each set. Let's begin with linear mapping. In a linear mapping, the difference between consecutive elements in both the domain and the codomain is constant. We have seen from previous slide that one-to-one relations and many-to-one relations are mappings. Basically, we are going to consider one-to-one relations. So in linear mapping, we say that the difference between consecutive elements in both the domain and the codomain are constant. Now this is what we mean. Let's look at this mapping. You can see that this is an example of a one-to-one relation, so it's a mapping. So 1 maps onto 1, 2 maps onto 2, 2 maps onto 3, 3 maps onto 5, 4 maps onto 7, and 5 maps onto 9. Now we are saying that if it is a linear mapping, this is the condition. The difference between consecutive elements, when you say consecutive element, 1, 2. So you see, after 1 you get 2, after 2 you get 3. 1 and 2, 2 is said to be consecutive after 1. So 1, 2, 3. So consecutive elements, from 1 you move to 2, from 2 you move to 3. That is what we refer to as consecutive. We are saying that the difference between consecutive elements in both the domain and the codomain is constant. The difference, what is the difference between 1 and 2? It's 1, right? The difference between 2 and 3 is 1. The difference between 3 and 4 is 1. The difference between 4 and 5 is 1. So you can see that between two consecutive elements, between 1 and 2, between 2 and 3, the difference is constant. It's not just for the domain. So in this case, this is the domain. It's also constant for the codomain too. So for the codomain too, you can see that the difference between 1 and 3 is 2. Difference between 3 and 5 is 2. Difference between 5 and 7 is 2. Difference between 7 and 9 is 2. So if it is a linear mapping, then the difference between consecutive elements in the domain and consecutive elements in the codomain must all be the same, or must be constant. They don't necessarily have to be the same. So the difference between consecutive elements in the domain can be different from difference between consecutive elements in the codomain. But what we mean that here you can see that for the domain, the consecutive elements, the difference between them are 1. For the codomain, the consecutive element, the difference between them are 2, and it's constant for both the domain and the codomain. When you have this, we say that you have a linear mapping. Let's look at another example. Looking at this example, you can see that difference between 0 and 1 is 1. Difference between 1 and 2 is 1. And it continues. It's going to be 1, 1, 1 for all of them. Difference between 2 and 5 is 3. Difference between 5 and 8 is 3. And it's also going to be the same for all of them. So we see that this is another example of a linear mapping. So once you are satisfied that it's a linear mapping, how do we find the rule or the formula that describes the mapping? The rule or the formula that can join members of the two sets, members of the codomain to members of the domain. The rule of a linear mapping with elements in the domain denoted by x and elements in the codomain denoted by y is given by y is equal to as plus b, where a and b are constants. Now what do I mean? Let's look at this example. If in this example you can see that we first have x maps onto y, then we have elements in the domain and elements in the codomain. So we are saying that we are describing all elements in the domain by the variable x. Then we are describing all elements in the codomain by the variable y. So what this statement is telling us that when you have something like this, when all elements in the domain is described by x and all elements in the domain is described by y, then the rule is given by y is equal to as plus b. A and b are the constants that you have to find, since we know that y and x are the variables that we have here. Y and x are what changes. If you watch the video on algebraic expression, you understand constants and variables. So y and x are what changes here. We have to find a constant that does not change. Now how do we do that? Let's pick some examples and see how this is done. So in this case, how do we find a and b? A is given by the constant difference of the codomain divided by the constant difference of the domain. I hope that is clear. So if you want to find a, we are saying that this is the constant difference of the codomain divided by the constant difference of the domain. So in this example, if you want to find a, we first have to find the constant difference of the codomain, and we divide it by the constant difference of the domain. The constant difference of the codomain here is 2. The constant difference are 2, 2, 2, 2, so it's 2. The constant difference of the domain is 1. So in this case, A is going to be 2 over 1, which is 2. It's easy, right? Now, how do you find B? B can be found by putting an element and its image in the rule. Let's make an example and see how this is done. So we are saying we are being told to find the rule of the following mapping. So we have A, B, and C. Let's pick the first one, A. So we have X maps to Y. Then we have been given some elements and their elements in the domain, their corresponding images in the codomain. I'm going to bring it here so that you can do the solution here. So what you do first is that you write the general rule. We are saying that the general rule for a linear mapping, we are satisfied that this is a linear mapping. This was the example that we were considering in the previous video. So when you are given the question, first check and see if it's a linear mapping. And it's a linear mapping because we already know that. So you write the general rule, which is y is equal to AS plus B. Now all you need to do is to find your A and find your B, then you substitute them in this equation. Very simple. So let's find A. We are saying that A is given by the constant difference of the codomain divided by the constant difference of the domain. The constant difference of the codomain is 2. Constant difference of the domain is 1. So you get 2. Now how did I find this? You can see that to find the constant difference, you can take an element, then in the domain, in the codomain here, and you subtract it from the previous element in the codomain. So when we take 3, you subtract 3 from 1. That will give us, you subtract 1 from 3. That will give us the constant element in the codomain. If you want to find the constant element in the domain, you can also take an element in the domain and you subtract the previous element in the domain from it. So in this case, when we take 2, we can subtract 1 from 2, and that will give us the constant element in the domain. I hope that is clear, because A is saying that A is the constant element of the domain divided by the constant element of the codomain. I picked the first 2 because they are usually smaller and easy to handle. So it's always easier to pick the first 2 elements. So I pick 3 and 1, then 2 and 1. Remember that they are dividing. So it's 3 minus 1 divided by 2 minus 1. 3 minus 1 gives us the constant element in the domain. 2 minus 1 gives us the constant element in the codomain. Somebody can decide to pick 9 minus 7 divided by 5 minus 4. It's the same thing. Another person can decide to pick 7 minus 5 divided by 4 minus 3. It doesn't change anything. It's the same thing. And we are getting 2. So after you have 2, we now know A. You substitute A in the equation here. So when you substitute A with 2, we are going to have y is equal to 2x plus b. We have found A. Now let's move on to finding B. In order to find B, this is what you do. You pick an element and its corresponding image of the mapping, and you substitute it into the equation that you have. Now this is what I mean. You come to the mapping and you pick an element and its corresponding image. Once again, I'm going to pick the first one because usually the first ones, the numbers there are smaller and they are easy to handle. So we can say that from the mapping here, when x is equal to 1, y is also equal to 1, because when x is 1, y is 1. Now if you have this, then we can substitute it into this equation and find B, because we know that y is equal to 2x plus b. So if y is equal to 2x plus b, right now we are saying that y is 1, so you can substitute y with 1 is equal to 2x. You know that 2x is the same as 2 times x, but we now know that x is also 1, so 1 is equal to 2 times 1 plus b. We can simplify and find B. That will give us 1 is equal to 2 times 1 is 2 plus B. So we can see that B will give us minus 1. So we now found A, we found B. So the rule is now y is equal to 2x minus b, because right now we have found b to be minus 1. So you place b here with minus 1, and that will give us y is equal to 2x minus b. With this rule, we can find any element in the domain and any element in the codomain. So let's say that if x, or the element in the domain here, is 5, all you need to do is to replace x with 5. So you are going to have 2 times 5 minus 1. 2 times 5 is 10. Minus 1 will give us the corresponding image here, which is 9. If the question tells you to find y when x is, let's say, 20, all you need to do is to replace x with 20 and you can find y. If the question tells you to find x when y is, let's say, 15, all you need to do is to replace y with 15 and you can find x. It is that simple. Let's consider the next example. We have xy here and we have been given the function. So once again, I'm going to bring the mapping. We have been given the mapping, sorry. So I'm going to bring the mapping here so that we can find it. So what you need to do is to first write your general formula, then you find a. We are saying that a will give us the constant difference of the codomain divided by the constant difference of the domain. So I'm going to take 5 minus 2 divided by 1 minus 0. And that will give us 3 divided by 1, which is 3. So we can replace a with 3. So y will give us 3x plus b. Now with this, all we need to do is to pick an element and its image. So as I said, I always like to pick the first one because the numbers there are usually smaller and easy to handle. So I'm going to pick when x is equal to 0, y is equal to 2. Then I substitute that in this equation to find b. So we are saying that y is 2. So I write 2 here is equal to 3 times x. X is now 0. So 3 times 0 plus b. And b will give me 2. So all I need to do is to replace b with 2. So y is equal to 3x plus 2. It's that simple. Let's consider the next example. So we have the mapping here. I'm going to bring it here so that we can write the solution here. So we quote the general rule, which is y is equal to as plus b. So the next thing we need to do is to find a. A will give us, so it's going to be the constant difference of the codomain divided by the constant difference of the domain. Constant difference of the codomain, I'm going to pick the first 2 elements. So I'm going to have 5 minus, but don't forget that this is already minus. So I'm going to have 5 minus 1 divided by 3 minus 0. 5 minus 1 will give me 5 plus 1. Then 3 minus 0 will give me 3. So this will give me 6 over 3, which is 2. Once I've found this to be 2, all I need to do is to pick an element and its image and see how to find b. I substitute it here to find b. So when x is 0, y is negative 1. So I'm going to replace y with negative 1, replace x with 0. So negative 1 is equal to 2 times 0 plus b. So b will give me negative 1. So I just substitute negative 1 in place of b, and that will give me y is equal to 2x minus 1. Once again, with this rule, you can find any image when a certain element has been given to you. So here, let's say the question tells you to find y when x is 23. All you need to do is to replace x with 23 and you can find y. Thank you for watching this video on mapping. Pick more examples on finding the rule of linear mapping and try your hands on them. Interact with me on my social media handles if you have any problem. See you in the next video where we will look at how to find the rule of an exponential mapping. Bye bye. We are still on the topic relations, mapping, and functions. We've considered relations. In the previous video, we looked at mapping and saw how to find the rule of a linear mapping. In this video, we are going to see how to find the rule of an exponential mapping. So let's look at exponential mappings. In an exponential mapping, the ratio between consecutive elements in the codomain is constant. What does this mean? Let's look at an example. In the previous video, we said that for linear mappings, the common difference between elements in the domain and elements in the codomain are constant. So in this example, you can see that if this were to be a linear mapping, we know that the difference between 1 and 2 is 1, difference between 2 and 3 is 1, difference between 3 and 4 is 1, difference between 4 and 5 is also 1. But let's look at the codomain. Difference between 1 and 4 is 3. Difference between 4 and 16 is not 3, Difference between 4 and 16 is 12. Difference between 16 and 64 is 48. And difference between 64 and 256 is 129. So you can see clearly from here that this is not a linear mapping, because the difference between consecutive elements in the codomain are not the same. So this can't be a linear mapping. So this is an example of an exponential mapping. So it says that in an exponential mapping, the ratio between consecutive elements in the codomain is constant. What is this ratio that we are talking about here? Now let's look at something. Let's divide 4 by 1. So we pick 4 here, we divide it by 1. So 4 divided by 1. I know you know this answer, but let's try it. You are going to get 4. Let's divide 16 by 4. If you take 16 and you divide it by 4, that is also going to give us 4. Let's divide 64 by 4. If you take 64, you divide it by, we are dividing 64 by 16. If you take 64, you divide it by 16, you get 4. Let's divide 256 by 64. If you take 256 and you divide it by 64, that is also giving us 4. Now, do you see what is happening here? You can see clearly from here that if we take consecutive elements in the codomain and we divide them, we are getting a common number or a constant, which is 4. So we take 4, we divide 4 by the previous number, and we are getting 4. We take 16, we divide by the previous number, we get 4. You take 64, you divide by the previous number, you get 4. You take 256, divide by the previous number, you get 4. That is what we refer to as the ratio or the common ratio. So you take 4 divided by 1, take 16 divided by 4, take 64 divided by 16, take 256 divided by 64, and you are getting constant values. So when you have this, we say that you have an exponential mapping. Remember that in exponential mapping, our main focus is on the codomain, not the domain. So we don't really pay much attention to what is happening in the domain. What we care about is what is happening in the codomain. For linear mappings, constant elements in the domain and codomain, consecutive elements in the domain and codomain must give, the difference must be the same. For exponential mapping, our focus is on the ratio of consecutive elements in the codomain. So the ratio between consecutive elements in the codomain for an exponential mapping must be constant. Let's look at an example of an exponential mapping. So we are concentrating on the codomain, not the domain. You know that from here the difference is constant, which is 1. But when you come here, difference between 1 and 3 is 2. But difference between 3 and 9 is not 2, it's 6. So straight away you can see that this is not an example of a linear mapping. This can't be a linear mapping. So you start to think of an exponential mapping. Now, 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. So you can see that if you take consecutive elements, the ratio between consecutive elements are also the same. Now this is what we refer to as an exponential mapping. When you have a mapping like this, we say that you have an exponential mapping. In the previous video, we saw how to find the rule of a linear mapping. Now let's look at how to find the rule of an exponential mapping. The rule for an exponential mapping with elements in the domain denoted by x and elements in the codomain denoted by y is given by y is equal to ar exponent x minus b, where a and b are constants. Now I'm going to explain this to you. What this means is that if you have an exponential mapping where elements in the domain are represented by x and elements in the codomain are represented by y, the rule is given by y is equal to ar exponent x minus b. Now how do we find this? We know that y and x are the variables. So what we have to find are a R, and B. How are we going to find that? A is the first term of the elements in the codomain. So if you have an exponential mapping, we are saying that A is the first term of the elements in the codomain. What are the elements in the codomain? Those are what we have here. So 1, 4, 16, 64, 2, 5, 6. A is the first term of the element. So A is the first element. So in this case, A is 1. That is A. What is B? B is the first term of the elements in the domain. This is the domain. So the first element in the domain is 1. That is B. So you can pick the A and B from the mapping straight away. A is the first term of the elements in the domain, and B is the first term of the elements in the codomain. Now what we are left with? R. Remember, we are finding A, R, and B. We found A and B. How do we find R? R is the common ratio of the elements in the codomain. So here, the common ratio. How do you find the common ratio? You take a number here, or take an element, and you divide it by the previous element. So you take 4, you divide by the previous element here, which is 1. And since that is constant, it will be the same for all of them. You can choose to take 16, you divide it by the previous element, you are still going to get 4. So here, the common ratio, R represents the common ratio. So we found A, we found B, we found R. We now have our rule. Let's pick some examples and see how this goes. Find the rule of the following mapping. We have A, B, C. We are going to pick them one after the other. Let's pick the first one. So we have X mapping to Y, then the mapping has been given to us. Once again, whenever you have a mapping, you have to check whether it is linear or exponential. We know this is exponential because we are finding the rule of exponential mapping. But when it's given to you, they are not going to specify in the question that it's linear or exponential. You have to check. You've seen how to check for a linear mapping, and you've seen how to check for an exponential mapping. Now let's see how to find the rule. I'm going to write it here so that you will be able to write our solution here. So we write the general rule. The general rule says that y is equal to AR exponent x minus b. Now what is A? A is the first element in the domain. So in this case, A is 1. Sorry, A is the first element in the codomain. So in this case, A is 1. What is B? B is the first element in the domain. That is also 1. So this is B. What is R? R is the common ratio. How do you find the common ratio? You pick an element in the codomain, you divide it by the previous element in the codomain. So 4, you divide by the previous one, which is 1. So 4 divided by 1. Somebody can decide to pick 256 divided by 64. But you can see that obviously it's easy to deal with 4 divided by 1 than dealing with 256 divided by 64. That's why it's always advisable to pick the first ones, because usually those numbers are smaller and they are very, very easy to handle. So you find A, you find B, you find R. You just substitute them into the equation. So A is 1, so you have 1 times. R is 4, so 4 exponent x minus B is 1, so 1. So this is going to give us, remember, 1 times any number is the same number. So 1 times 4 exponent x minus 1 is the same as y is equal to 4 exponent x minus 1. It is that simple. So with this rule, you can find any x value when y is being given to you, or you can find any y value when x is given to you. All you need to do is to substitute it here. So let's say after you have done this, the question tells you to find y when x is, let's say, 20. All you need to do is to change x and replace 20 with x here. So you are going to have 4 exponent 20 minus 1, which is 4 exponent 19, and you'll be able to find y. It is very, very simple. Let's look at the next example. We have this mapping here. So x maps onto y. So we quote our general equation. The general equation says that you have y given a r exponent x minus b. What is A? A is the first element in the codomain. The first element in the codomain is 1. What is B? B is the first element in the domain. In this case, B is 0 because the first element in the domain is 0. What is R? R is the common difference. So I said the common difference, sorry. R is the common ratio. How do you find the ratio? You take an element in the codomain and you divide it by the previous element. So you take an element, let's say 3, you divide it by the previous element, which is 1. Once again, you can divide to take 27 and divide it by 9. I choose to take the first two because the numbers there are smaller. So 3 divided by 1 will give us 3. After this, all you need to do is to replace or substitute what you have here into the general equation. So this is going to give us y is equal to 1 times 3 exponent x minus 0. Since a is 1, b is 0, and r is 3. And this will give us y is equal to 3 exponent x. And this is true because if you put x is equal to 0, you are going to have 3 exponent 0, which is 1. So y will give us 1. When you put x is equal to 1, you are going to have 3 exponent 1, which will give us 3. When you put x is equal to 2, you are going to have 3 exponent 2, which is 9. When you put x is equal to 3, you are going to have 3 exponent 3, which is 27. The same thing applies to 3 exponent 4, which is 81. So after you found the rule, you can even use the mapping that have been given to you to check whether your answer is right or not. Let's look at the last example in this video. So you have been given this mapping here. I'm going to shift it here so that you can write our solution for you to see it very well. We quote our general rule, which is y is equal to ar exponent x minus b. Now what is a? A is the first element in the codomain. The first element in the codomain is 32. So we are going to pick 32. What is b? B is the first element in the domain. The first element in the domain is minus 1. So we pick that. What is R? R is the common ratio. How do you find the common ratio? You pick the first element, you pick an element and you divide it by the previous element. So here I'm going to pick 16 and divide it by the previous element, which is 32. So I pick 16, I divide it by the previous element here, which is 32. So nothing changes, you follow the same format. I simplify 16 over 32 and I'm going to get 1 over 2. Once again, when you come here, it could have been easier if I pick 4. It could have been easier if I pick 4 and 2, because 2 divided by 4 will also give me 1 over 2. Very, very easy. I decided to pick 16 over 32 because I like picking the first two elements. Now let's continue. So what we do is that we replace every element here. We replace what we have found in the equation. So we replace a with 32, we replace b with minus 1, and we replace r with 1 over 2. So let's move on. So we have 32 times r is now 1 over 2. I brought the bracket because it's a fraction. So 1 over 2, then exponent x minus, remember there's minus here and the b coming is also minus, so I'm going to have x minus minus 1. Now let's proceed. We know from indices that 32 is the same as 2 exponent 5. 2 exponent 5 will give you 32 times, whenever you have 1 exponent 1 over 2, you can write it as 2 exponent minus 1. If you watch the video on indices, you are going to understand how this is done, why this is so. So you have half being the same as 2 exponent minus 1. There's already this here, which is x minus minus 1, which will give us x plus 1. So 2 exponent minus 1 will multiply s plus 1. Watch the video on indices and you get how this computation is being done. Now this is going to give us y is equal to 2 exponent 5 times 2 exponent minus 1 times x will give us minus x, minus 1 times 1 will give us minus 1. Now from indices, we know that when you have two numbers multiplying and they have the same basis, you can add the exponents. So here, since we have 2 and 2 here, we can add the exponents. So we add 5 to minus x minus 1. And that will going to give us 2 exponent 5 minus x minus 1. And this, if we simplify, we are going to have 2 exponents. Y is equal to 2 exponent 4 minus x. So you see, when you get to this side, it's indices from here. So if you watch the video on indices, you see how all these computations were done. So what you have to understand is how to find the A, how to find the B, and how to find R. From there, you can proceed with the computation. If you are not so clear on how this calculation was done, watch the video on indices and you will see how to do these computations. You can also try other examples and you'll be able to solve rule for exponential mapping. So with this rule that we have found here, you can find any x value when y is given to you, and you can also find y values when x is being given to you. Thank you for watching this video on exponential mapping. See you in the next video, where we will consider a slightly different type of mapping. In this type of mapping, they are neither exponential nor linear. When you have that, we are going to learn how to find the rule of such a mapping. Bye bye. We are on the topic relations, mapping, and functions. In the previous video, we learned how to find the rule of an exponential mapping. In this video, we are going to learn how to find the rule of a mapping that is neither exponential nor linear. Finding the rule of a mapping by inspection. Sometimes, a mapping may be neither linear nor exponential. In such a case, the rule can be found by inspection. Let's pick an example of such a mapping. Look at this example. You can see from here that the common difference between elements in the domain. Let's look at that. 3 minus 0 will give us 3. 5 minus 3 will give us 2. 7 minus 5 will give us 2, and 9 minus 7 will give us 2. So between these consecutive elements, between 3 and 5, between 5 and 7, between 7 and 9, the difference is 2. But between 0 and 3, the difference is 3. So it is not the same. For a linear mapping, we know that the difference between all of them, consecutive elements, must be the same. Let's come to the codomain. Between 0 and 6, the difference is 6. Between 6 and 10, the difference is 4. Between 10 and 14, the difference is 4. Between 10 and 18, the difference is 4. You can see the difference between 6 and 10, 10 and 14, 14 and 18 are constant. But the difference between 6 and 0 is 6. So this is not linear, because for linear, the difference between consecutive elements in the domain and difference between consecutive elements in the codomain are all the same. So here, difference between consecutive elements in the domain, if it was linear, they were all supposed to be the same. The difference between consecutive elements in the domain here, if it were to be linear, they were all supposed to be the same. So we are certain that this is not linear. Let's check and see if this is exponential. For exponential, we are saying that the common ratio between consecutive elements in the codomain must be the same. So let's check. 6 divided by 0 is 0. 10 divided by 6 will give us 10 divided by 6 will give us 5 over 3. So clearly we have seen that 0 and 5 over 3 are also not the same. 14 divided by 10 will also give you something different, and 18 divided by 14 will also give you something different. So you can see from here that this is neither linear nor exponential. Let's look at another one. So here, elements in the domain are being described by A, elements in the codomain are described by B. Let's check here. You can see that between 0 and 1, the difference is 1. Between 1 and 2, the difference is 1. Between 2 and 3, the difference is 1. Between 3 and 4, the difference is 1. So here, the common difference between elements in the domain are constant. Let's check and see for the codomain. Between 1 and 0 and 1, the difference is 1. But between 1 and 4, the difference is 3. Between 4 and 9, the difference is 5. So you see, it keeps changing. For it to be linear, the difference between the consecutive elements in the domain must be the same. Difference between consecutive elements in the codomain must also be the same. So this is not linear. Let's check and see if this is exponential. For exponential, the common ratio between consecutive elements in the codomain must be the same. So let's try 1 divided by 0 is 0. 4 divided by 1 is 4. 9 divided by 4 will give you 9 over 4. So you can see from here that the common ratio between consecutive elements are also not the same. So this is also not exponential. So in both cases, the mapping is neither linear nor exponential. So how then do we find the rule or the formula? This can be found by what you call inspection. You inspect the elements in the mapping. How do you do this inspection? Let's pick some examples and see how this is done. Find the rule of the following mapping. So let's pick the first one. This is also the example that we are considering in the previous video. We are certain that it is neither linear nor exponential. Once again, when the question is given to you to find a rule, they are not going to tell you this is linear, this is exponential. No, you have to check for it. We have checked this from the previous slide and we have seen that it is not linear, it is not exponential. So we are going to find a rule by inspection. So let's inspect. By inspection, you see, if you take the first element in this image, 0 and 0, you can't draw any meaningful conclusion from 0 and 0. So let's pick the next one. We have 3 and 6. The next one, we have 5 and 10. The next we have 7 and 14. The next we have 9 and 18. Now if you look at this very carefully, you can see that to get the image 6 here, if you multiply 2 by 3, we are getting the image 6. To get the image 10, if you multiply 2 by 5, we are getting 10. To get the image 14, if you multiply 2 by 7, we are getting 14. To get the image 18, if you multiply 2 by 9, we are getting 18. Now you can see a common pattern is repeating itself. Even if you pick 0, if you multiply 2 by 0, you are getting 0. So a common pattern is repeating itself. You multiply 2 by the elements in X and you are getting the image. So if you take this element here, you multiply it by 2, you get this. If you take this, you multiply it by 2, you get this. If you take this, you multiply it by 2, you get this. If you take this here, which is 9, you multiply it by 2, you get 18. So something is repeating. There's a common pattern. What this tells us that if you want to get Y, all we need to do is to take X and multiply it by 2, or multiply 2 by what you have in X. So the rule is Y is equal to X times 2. It is very simple, right? By inspection, we are able to see this. If you want the image, which is Y, all you need to do is to take X and multiply it by 2, because that is what we have been seeing. So if the next one is 10, or maybe if the next one is 9, if the next one is 11 or 12, all you need to do is to multiply that with 2 and you are going to get this. We saw this by inspection. That is why we say that we are doing it by inspection. So the rule is Y is equal to 2x. Let's look at the next one. We have the mapping. This time the elements in the domain is described by A, elements in the codomain is described by B. Now let's look at this very well. A maps onto A, 0 maps onto 0. As I said, it's usually difficult to draw conclusions from 0 mapping to 0. So let's consider the next one. Here 1 maps onto 1. That is also quite difficult. Let's pick the next one. 2 maps onto 4. 3 maps onto 9, 4 maps onto 16. Now look at something here. You can see that if you take 2 and you square it, you are getting 4. If you take 1, you square it, you are getting 1. If you take 0, you square it, you are getting 0. If you take 3 and you square it, you are getting 9. If you take 4 and you square it, you are getting 16. So a pattern is repeating. What you have to do is that to get B, you have to take A and square it. So here, A here is 2, B is 4. So to get 4, which is B, all you need to do is to take A and square it. So you see that by inspection, you can see that 1 is equal to 1 squared. 4 is equal to 2 squared. 9 is equal to 3 squared. 16 is equal to 4 squared. So there is a pattern repeating. There's a pattern repeating. And the pattern is that if you want B, all you need to do is to take A and square it. So this is the rule of the mapping. B is equal to A squared. So whenever you are being given a mapping that is not linear nor exponential, all that you have to do is to study the mapping, inspect the mapping, and you can see that there is a common pattern. Use that pattern to form the rule. And here the pattern is that if you want the image, which is B, take the element and square it. So if you want the image of 2 here, it's going to be 2 squared, which is 4. The image of 3 is going to be 3 squared, which is 9. The image of 4 is going to be 4 squared, which is 16. So the image of 5 is going to be 5 squared, which is 25. Image of 6 is going to be 6 squared, which is 36. So the order continues. So we have been able to find the rule of this mapping. Let's look at the next example. The mapping has been given to us here. Elements in the domain are described by X. Elements in the codomain are described by Y. Let's find the rule of this mapping. Now by inspection, it can be seen that both the numerators and the denominators follow the rule for linear mapping. Therefore, find the rule for the numerator and the denominator separately. Now this is what I mean. We are certain that this is not linear, this is not exponential. So we have to find a way of finding the rule. Now this is a fraction. You know that fractions have a numerator part and a denominator part. So let's consider the numerators. If you consider the numerators, you can see that we have 5, 8, 11, 14, and 17. Difference between 5 and 8 is 3. Difference between 8 and 11 is 3. Difference between 11 and 14 is 3. Difference between 14 and 17 is also 3. So you can see that the difference between consecutive elements is constant, and that is follows a linear mapping. Since we are certain that the one in the domain here, difference between this one and this one is 1, between 2 and 3 is also 1, between 3 and 4 is 1, between 4 and 5 is also 1. So that is constant. Now we are also seeing that if you take the numerators, the difference between consecutive elements is also constant. So that follows linear. In the domain, the common difference is constant. In the codomain, the common difference is also constant. So that follows a linear pattern, right? So it means that the numerator follows a linear pattern. Let's look at the denominator. Difference between 8 and 13 is 5. Difference between 13 and 18 is 5. Difference between 18 and 23 is 5. Difference between 23 and 28 is also 5. So you see that the denominators is also following a linear pattern, since the common difference is also 5. So if this happens, what you have to do is that find the rule for the numerator separately and find the rule for the denominator separately. How is this done? Let's see. Rule for the numerator. Because we are finding the rule for the numerator, we are going to assume that the denominators don't exist. So the denominator is taken off. Remember, the denominator used to be there. But because we are finding for the numerator, we are assuming that the denominator don't exist. Now, this is the mapping that we need to deal with. 1 maps to 5, 2 maps to 3, 3 maps to 11, 4 maps to 14, and 5 maps to 17. Now you can see that this is a linear mapping. So we can find the rule for this linear mapping that we are seeing here. So to find the rule, we quote the general rule for a linear mapping. We know that is y is equal to as plus b. We have already done this in a previous video, so you know how this is done. Now what is a? A is the common difference in the codomain divided by common difference in the domain. Common difference in the codomain will be given by, in this case, I'm picking the first two elements, so 8 minus 5 divided by 2 minus 1. We have seen from previous video how this is done. So this is A. We have found A, so we replace 3 with A. So we are going to have y is equal to 3x plus b. To find b, we know that we are going to pick an element and its image, then we can use it to find b. So I'm picking the first one. When x is equal to 1, y is equal to 5. So this is going to give us 5 is equal to 3 times 1 plus b, since y is 1 and since y is 5 and x is 1. Sorry. So this is going to give us 5 is equal to 3 plus b, and b will give us 5 minus 3, so b is equal to 2. So we have now found b, so we can replace b with 2. So for the numerator, the rule is 3x plus y is equal to 3x plus 2. Now we are done with the numerator. Remember, we said that the denominators also follow a linear mapping, so we need to find the rule for the denominators too. So find the rule for the denominators. This time, because we are finding for the denominators, we are going to assume that the numerators are also not there. So this is the mapping that we are dealing with now. 1 maps onto 8, 2 maps onto 13, 3 maps onto 18, 4 maps onto 23, and 5 maps onto 28. Now this is an example of a linear mapping. So we find the rule of this linear mapping. We quote the general rule, which is y is equal to as plus b. A will be given by, in this case, we have 13 minus 8 divided by 2 minus 1. Then this is going to give us 5. Since 13 minus 8 is 5, 2 minus 1 is 1. So 5 divided by 1 is 1. So we replace a with 5, and this will give us y is equal to 5x plus b. Now let's find b. I'm going to pick the first element and its image. So when x is equal to 1, y is equal to 8. You replace y with 8 and x with 1, and that will give us 8 is equal to 5 times 1 plus b. This will give us 8 is equal to 5 plus b, and b will be given by 8 minus 5, so b is 3. So we can now replace b with 3. So we can say that therefore y is equal to 5x plus 3. So this is the rule for the denominator. So now we can see that we have found the rule for the numerator and rule for the denominator. So the rule for the mapping will be equal to y is the same as rule for the numerator, which is 3x plus 2, divided by rule for the denominator, which is 5x plus 3. So from inspection, we saw that the rule for the numerator follows a linear mapping. Rule for the denominator follows a linear mapping. So we found the rule for the numerator, you found the rule for the denominator. So after you finish the whole thing, y is going to be given by the numerator divided by the denominator. So whenever a mapping is given to you, all you need to do is to check whether it is linear or exponential. If it's not linear and it's not exponential, then it means that you have to find the rule by inspection. Thank you for watching this video, and pick more examples on finding rules of mapping. Try your hands on these examples. Interact with me on my social media handles if you have any problems, and I'll help you to solve it. See you in the next video, where we will consider the last part of our topic, which is functions. Bye bye. We are on the topic relations, mapping, and functions. In previous videos, we've considered relations and mapping. In this video, we are going to look at the last part, which is functions. So what is a function? A function is a mapping in which each element in the domain map onto one and only one member in the codomain. We looked at mapping in the previous video. So for a function, each element in the domain will map onto one and only one member in the codomain. So each element in the domain will have only one image in the codomain. Just as it is for mapping, functions are also defined by a rule or a formula. So in a function, we will be given a rule or a formula. Then using that rule or a formula, we can find images of elements, or we can find images of elements or images of members in the domain. Now, a function of x is written as f is to x, or f into bracket x, and this is read as f of x. So f into bracket x is read as f of x. This is also read as f of x. So a function of x is usually written as f is to x, or f into bracket x, and it's read as f of x. Remember, you can use any letter in place of f here. So it can be g of x, it can be h of x, but because it's a function, we usually use the letter f. So you are going to see f most of the time. Examples are, so we have f of x is equal to x plus 2. So this is a function of x. That is why we have x here. We have g of a. This is a function of a. So you see that the variable here is a. We have f of n. This is a function of n. So we have, that's why we can see n here. So f of n is equal to n raised to the power 3 minus 4n plus 2. So under functions, we are usually going to be given the rule or the formula. Then we will be told to find images of elements in the domain. Sometimes the images will be given to us, and we will be told to find the elements in the domain that maps onto that image. Let's pick some examples and see how this is done. So we have quite a number of questions here. We have about 4 of them. Take note of it. We are going to solve it one after the other. Let's pick the first one. We are told to find the image of -1 under f of x is equal to negative s raised to the power 3 plus 3x minus 5. So here we are finding the image of -1, which means that -1 is in the domain. Then we have to find its corresponding image in the codomain. I hope that is clear, right? So to find the image of -1, what you have to do is that you have to find f of -1. You see, this is the function. So f of x is given as this. So to find the image of -1, you need to find f of -1. That is f into bracket -1. So we are going to replace x with -1, since we are finding the image of -1. So in a way, this is what we mean. We have -1 here. So -1 is here. Now -1 is mapping onto a certain image that we want here. -1 is mapping onto a certain image x that we want here. Now this is the function that is helping us to find that image. So all that we need to do is that, we need to put -1 into this relation, here. Sorry, we have to put -1 into this rule or this formula here, and we are going to get the image, the corresponding image of -1. So to find the image of -1, we say that we find f of -1. If you are finding f of -1, which means that we are replacing every x we see with -1. So it's going to give us f of -1 will give us negative, then we bring our bracket, since this is a negative, -1 exponent 3 plus 3 into bracket -1, which here is x, so you bring -1 minus 5. Now let's proceed. -1 exponent 3 will give us 3. So -1 exponent 3 will give us -1. So this is going to give us -1 minus 1, and that is going to be +1. Then 3 times -1 will give us -3, then minus 5. So this is going to give us 1 minus 3 minus 5, and that is going to give us minus 7. So what this means is that if you have negative 1, then you process negative 1 using this rule or this formula, you're going to get an image of negative 1. So the image of negative 1 under f of s is negative 7. I hope this is clear. Let's move on to the next example. A function is defined by f of x maps to 2x minus 3 on the domain negative 2, negative 1, 0, 1, 2. Find the range of the function. Find the range of the function. Now, when the function is given to you in this form, we change f is such that f is to x. You change that into f into bracket x. Then whenever, after you've done that, the arrow sign will change to an equal to sign. Then we have the function here, so 2x minus 3. So whenever you are being given this, to work with it, we change f is to x into f into bracket x. Then you change the arrow sign to an equal to sign. Then the function will be given. Remember that what we have here is the same as this. So we have f of s is equal to 2x minus 3. And we are saying that this is the definition of the function. This is the map. This is the rule of the function. This is the formula of the function. And this function is given on the domain. These are members in the domain. Negative 2, negative 1, 0, 1, 2. Find the range of the function. Remember that in the first video, we explained what the range is. We said the range is the set of possible images in the codomain. What that means is that we have to find the members in the codomain. So all that this question is telling us to do is that these are members in the domain. So we should find members in the codomain. So when you have negative 2 in the domain, what will it give you in the codomain? If you have negative 1 in the domain, what will you get in the codomain? If you have 0 in the domain, what will you get in the codomain? If you have 1 in the domain, what will you get in the codomain? And if you have 2 in the domain, what will you get in the codomain? So we have to find the image of negative 2, image of negative 1, image of 0, image of 1, and image of 2. We know that to find the image of negative 2 is going to be, we are going to say that when x is equal to negative 2, if x is equal to negative 2, then we are replacing x here with negative 2. So we are going to find f of negative 2. F of negative 2 is going to give us 2 into bracket minus 2 minus x, since we are replacing x with minus 2. And this will be the same as 2 times minus 2 give us minus 4. We have minus 3 here. Minus 2 minus 4 minus 3 will give us minus 7. So we found the image of negative 1. Then you move ahead and find the image of, you find the image of negative 2, sorry. You go ahead and find the image of negative 1. To find the image of negative 1, we say that when x is equal to negative 1, we are going to have f into bracket negative 1, which means we are finding f of negative 1. And this is going to give us 2 into bracket minus 1 minus 3. 2 times minus 1 will give us minus 2 minus 3. So we are going to have minus 2, then minus 3. Minus 2 minus 3 will give us minus 5. So the image of negative 1 under this function is negative 5. We move ahead and find for 0. Remember, we are finding the range. So we find all possible images. So we find all the elements in the codomain. So 0. When x is 0, we are going to find f of 0. It's going to give us 2 times 0, or 2 into bracket 0, then minus 3. This will give us 0 minus 3, and we are going to have negative 3. We move ahead and find f of 1, or when x is equal to 1. When x is equal to 1, we are going to have f of 1, and that will give us 2 times 1 minus 3. That will be 2 minus 3, and that is going to give us negative 1. We find when x is equal to 2, we are going to find f of 2 is going to be 2 times 2, then minus 3. It's going to give us 4 minus 3, which is 1. So from here, we can see that we have found f of negative 2, we got negative 7. We found f of negative 1, we got negative 5. We found f of 0, we got negative 3. We find f of 1, we got negative 1. We found f of 2 and we got positive 1. So the image of negative 2 is negative 7. The image of negative 1 is negative 5. The image of 0 is negative 3. The image of 1 is negative 1. And the image of 2 is 1. So we can say that therefore the range is negative 7, negative 5, negative 3, negative 1, and 0. These are the set of possible images of the domain under the given function. Let's move on to the next example. The image of a function defined by f of x given as 2x plus 5 is 15. Find x. Now let's look at this very well. This time we have not been given the elements and we have to find the image. It's the other way around. We have been given the image, so we have to find the element producing the image. I hope that is clear. Instead of, you see, in the previous examples, we are always been given the function, then we have been given the element to find the image. This time the image has been given to us, so we are supposed to find the element producing that image. As I said, if you have the function in this form, you change f is to x into f into bracket x. We change the arrow sign to an equal to sign, then we have 2x plus 5 as we have here. Now we are saying that this whole function, what we have here, 2x plus 5, is 15. A certain element is given as, if you replace x with a certain element, it changes the whole thing to 15. Now what is that element producing that result? So if that happens, what you have to do is that you have to equate what we have here to the image. So we equate f of x to the image, because what the question is telling us that there is a certain value here, or there is a certain element here. If you replace that x with that element, you are getting 15. What is that element? So it means that finally f of x is going to give us 15. You know that same f of x is 2x plus 5. So if f of x is 2x plus 5 and f of x is giving us 15, then we can equate these two. So we can equate 2x plus 5 to 15. From here we can make x the subject, so we bring 5 here. That's going to give us 2x into bracket 5x minus 5, 15 minus 5. If you watch the video on solving linear equations, you understand how this is being done here. So this is going to give us 2x into bracket 10. We divide both sides by x and we are getting 5. So what that means is that 5 is the element that is producing the image 15. So if we have x to be 5, let's try and find f of 5 and see. If you find f of 5, it's going to be f into bracket 5 here. So we replace x with 5, it's going to be 2 times 5, which is 10, plus 5, and that will give us 15. So under this function, 15 is the image of 5. So the image was given to us and we have now found the element to be 5. So in the previous examples, we are being given the element and then we are told to find the image. In this example, we have been given the image and we have been able to find the element. I hope this is clear. Let's look at the final example. Given that f of x is equal to ax plus b, find the value of a and b if f of 2 is equal to 4 and f of 4 is equal to 10. So here we have been given the element, we have been given the rule, or the formula is ax plus b. Now we are being told to find a and b, which are the constants, and in able to do that, we are being told that f of 2 is 4 and f of 4 is 10. So we can use these two information that we have here to find a and b. So let's begin with the first one. We know that f of 2 is 4. We have been given f of 2 is 4. So we can also find f of 2 here in this general rule that has been given us. Then we equate that to 4 and see if we can find. F of 2 has been given to us as 4. So let's try and find f of 2. If you find f of 2 here, which means that you replace x with 2, right? This is going to give us 2a times 2, which stands for x here, then plus b, and this is going to be 2a plus b. Now we know that f of 2 is 4. We have also been able to find f of 2 as 2a plus b, so we can equate 2a plus b and 4. So we can say that 2a plus b is equal to 4. So this is simple, right? The question told us that f of 2 is 4. We have also been able to find that f of 2 from this rule or this formula, that f of 2 is the same as 2a plus b. So if f of 2 is 2a plus b and at the same time f of 2 is 4, then we can equate 2a plus b to 4. We are going to call this equation 1. Whenever you see this, you start to think of simultaneous equation. Let's move on to the next part. We know that f of x is equal to as plus b. The second information that was given to us was that f of 4 is 10. So let's try and find f of 4 from the general rule here. From the general rule, f of 4 will give us a times 4 plus b. Since this time x is 4, and this is going to give us 4a plus b. Now f of 4 is 10, and at the same time f of 4 is 4a plus b. So it means that we can equate 4a plus b to 10. So we have 4a plus b is equal to 10. So now this will be equation 2. So we have equation 1, we have equation 2. So we can solve these two since we have simultaneous equations in two variables. So let's solve this by using the method of solving simultaneous equations. For the sake of this example, I'm going to use the elimination method. If you watch the video on solving simultaneous equation in two variables, you will see that there are other methods to also solving this. And if you watch that video, you understand how to solve simultaneous equation. In that video, we took a lot of examples on solving simultaneous equations, so you see how this is done. Now, I'm going to subtract equation 2 from equation 1. We've done a lot of this in the video on simultaneous equations, so I encourage you to go and watch that video too. So equation 1 minus equation 2 is going to give us 2a minus 4a plus b minus b equal to 4 minus 10. And this is going to give us minus 2a is equal to minus 6. We divide both sides by minus 2 and a will give us 3. So we have found a to be 3. We need to find b. So I'm going to substitute a into the first equation here. So we know that 2a plus b is equal to 4, but we have found a to be 3. So I place a with 3. That will give us 2 times 3 plus b is equal to 4, which will be 6 plus b is equal to 4. So b will give us minus 2. So from this, we have been able to find a to be 3 and minus 2. So all that you need to do is that look at the function that have been given to you, look at the rule that have been given to you, then follow the principles that we used in this video, and you'll be able to solve questions like this. Thank you so much for watching this video. Pick more examples on solving questions under functions and try your hands on them. Solve more. If you have any problem, interact with me on my social media handles and I'll help you to understand this very well. See you in the last video on relation mapping and functions, where we will consider how to find numbers or how to find values that makes a function undefined. Bye bye. This is the final video on relations, mapping and functions. We've considered relations and mapping. In the previous video, we looked at functions. We saw how to find the image and element of a function when the rule or formula of the function has been given to you. In this video, we are going to learn how to find the values that make a function undefined. Now, what do we mean by undefined? Any expression of the form g of x over f of x over g of x is undefined if g of x is equal to 0. So what we mean is that if you have a function of this form, a function that is in the form of a fraction, a function over a function, then we are saying that the whole function is undefined if the denominator is equal to 0. Now this is what I mean. Please take your calculator and switch it on. Now type 1 over 0, then press equal to. What do you get? Math error. That is the undefined we are talking about. Whenever you type anything over 0, let's say type something like random, type 8 over 0, you are going to get undefined. So whenever you type anything over 0, your function is going to be undefined. So what it means is that if you have a function that is in the form of a fraction, like what we have here, a function over another function, and the denominator is 0, then your function is undefined. That is why your calculator gives you math error. So if you want to find the values that make a function undefined, equate the denominator of the function to 0 and solve for the variable there. It's as simple as that. Let's pick some examples and see. So you have been given about 3 questions here. You pick them one after the other and solve. So the first one says that find the value of x for which f of s given us 4 over x plus 3 is undefined. So as we said, whenever you have this f is to x, you change the f is to s into f into bracket x, then you change the arrow sign into the equal to sign. So you have 4 over x. So we have f of x is equal to 4 over x plus 3. Now to find the value that makes this function undefined, we say that equate the denominator. Remember that don't pay attention to the numerator. Don't worry yourself with anything on the numerator. Equate the denominator to 0. Because if you're able to get the denominator to be 0, then the whole function, no matter what is on the numerator, will be undefined. So to make this function undefined, if s plus 3 is equal to 0, then f of x will be undefined. So if the denominator is equal to 0, then the whole function will be undefined. So equate the denominator to 0 and solve for x. So s plus 3 is equal to 0. To find x, we know that we bring 3 to this side, so we are going to have x is equal to negative 3. So what this means is that the value of x for which f of s is undefined is negative 3. So if x is equal to negative 3 in this function, then the whole function will be undefined. Now let's look at this. If you replace x with negative 3, you are going to have negative 3 plus 3, that will be 0. So you are going to have 4 over 0, and that will make the whole function undefined. So s can be any other number, but immediately s becomes negative 3, this whole function here becomes undefined. Let's look at the next example. Find the value of x for which if h of x is equal to s squared minus 5x all over s squared minus 4x plus 3 is undefined. Once again, to make a function undefined, the denominator must be equated to 0. Don't worry yourself with what is on the numerator. Immediately the denominator becomes 0. Anything on the numerator doesn't matter. The whole function will be 0. So to find the value of x that will make this function h of x undefined, we equate what is on the numerator to 0. So we are saying that if s squared minus 4s plus 3 is equal to 0, then h of x will be undefined. So don't worry yourself with what is here. Equate the denominator to 0. Sometimes to find value of x that will make a certain function undefined, the question will tell you to find the zeros of the function. It's the same thing. When the question tells you to find the zero of the function, the same as find the number or the value that will make the function undefined. So here we are being told to find values of x that will make this function here undefined. So we equate the denominator to 0. So we solve s squared minus 4s plus 3 is equal to 0. This is a quadratic equation. If you watch the video on solving quadratic trinomials under algebraic expression, you will get how to solve this quadratic trinomial into details. We've solved more examples in that, so I'm going to go ahead and solve this quadratic trinomial. So you multiply the coefficient of x squared here, which is 1, by this one here, which is 3. So you are going to get 3. Then we look for two numbers that when you multiply you get positive 3. When you add, we are going to get negative 4, and that will going to give us negative 1 and negative 3. So we replace negative 4 with those two numbers. So this is going to give us x squared minus x minus 3x plus 3 is equal to 0. Once again, we've solved more examples on solving quadratic trinomials under algebraic expressions. So please go and watch that video and you understand how these two numbers came about. Let's simplify. Let's factorize. So we factorize x out. We are going to get x into bracket x minus 1, then minus 3 into bracket x minus 1 is equal to 0. As I said, we have a negative sign here. So whenever you have a negative sign here and you factorize something out, the sign here, if it's positive, it changes to negative as we have here. So we are going to have, we have x minus 1 here, we have x minus 1 here. So we pick one of them, then you pick x minus 3 is equal to 0. Once again, if you watch the video on solving quadratic trinomials and algebraic expressions, you are going to get this very, very well. So as is the case, we equate what is in the first bracket to 0 and we solve. So we have x minus 3 is equal to 0, so x will be equal to 3. We have x minus 1 is equal to 0, so x is equal to 1. So which means that the value of x that will make h of x undefined are 3 and 1. So if you put x is equal to 3, the h of x will be undefined. If you put 1, x is equal to 1, h of x will be undefined. You can try that and you see that whenever you put x is equal to 3 or x is equal to 1, the denominator of the function, which is h of x, will be 0. Let's look at the next example. F of x is defined by, a function is defined by f of x giving us 3x minus 1 over x minus 3 on the domain negative 1, negative 2, negative 1, 0, 1, 2. I find a range. What element of the domain corresponds to the following images? A, 7 over 5 and B, 1. Then what value of x makes the function undefined? So we are supposed to find the range here again. We did an example in the previous video and we are going to do this one too. So the first thing you have to do is to write the function like this. So f of x is equal to 3x minus 1 over x minus 3. So we are supposed to find the range. So in finding the range, we are going to find the corresponding images of these elements in the domain. So we find the corresponding image. So the first element is negative 2. So you find the image of negative 2. We have f of negative 2 to be equal to 3 into brackets minus 2 minus 1 all over minus 2 minus 3. This will give us minus 6 minus 1 divided by minus 5. Then we have 7 over 5. We find the image of the next element, which is minus 1, and that is going to give us 3 into brackets minus 1 minus 1 all over minus 1 minus 3 is equal to minus 3 minus 1 over minus 4. Minus 3 minus 1 will give us minus 4. So minus 4 over minus 4 will give us 1. You find the image of the next element, which is 0. 3 into bracket 0 minus 1 over 0 minus 3. And this is going to give us 0 minus 1 over minus 5, giving us 1 over 5. Then we find the image of the next element, which is 1. So that is going to give us 3 into bracket 1 minus 1 all over 1 minus 3. We are going to have 3 minus 1 over minus 2, and that will give us minus 1. Then you find the image of the next one, which is 2. So we are going to have 3 into bracket 2 minus 1 all over 2 minus 3 into bracket 6 minus 1 over minus 1, and that will give us minus 5. So to find the range, all you need to do is that you find the images of the elements in the domain. Then when you put all those images together, you have the range. So from here we have seen that f of negative 2 will give us 7 over 5. f of negative 1 will give us 1, f of 0 will give us 1 over 5, f of 1 will give us negative 1, f of 2 will give us negative 5. So we can see that the image of negative 2 is 7 over 5, the image of negative 1 is 0, is 1, the image of 0 is 1 over 5, the image of 1 is negative 1, and the image of 2 is negative 5. So you can see that the range is 7 over 5, 1, 1 over 5, negative 1, and negative 5. So these are the corresponding images of the elements that we have in the domain. They make up what is called the range. Let's look at the next question. What element of the domain corresponds to the following images? So what this question is telling us that there are these elements in the domain. There are these elements in the domain here, 7 over 5, and what elements of the domain correspond to the following images? There are these elements in the images, the codomain or the range, that have corresponding images, that have corresponding elements in the domain. So we should find those elements. So all the question is telling us that when you come here into the range, we have 7 over 5 and 1. What in the domain is giving us 1? That is all that it means. What element in the domain is giving us 1 in the codomain or the range? And we know that negative 2 is mapping onto 1. So negative 2 is mapping onto 7 over 5. Negative 1 is mapping onto 1. So in the first instance, the element giving us 7 over 5 in the range is negative 2. From the range, the element of the domain corresponding to 7 over 5 is negative 2, because we know that the image of negative 2 is 7 over 5. And in the same way, the element giving us 1, the element in the domain that is giving us 1 is negative 1, because from the calculation that we did, we saw that the image of negative 1 is 1 in the domain or the range. I hope that is clear. In the same way, the image of 0 is 1 over 5, the image of 1 is negative 1, and the image of 2 is negative 5. Let's look at the next one. What value of x makes the function undefined? We've seen that to make a function undefined, you need to equate the denominator to 0. So we know that if x minus 3 is equal to 0, then the function will be undefined. So equate x minus 3 to be equal to 0. Equate x minus 3 to 0 and find x. X minus 3 is equal to 0, so x will give us 3. So what this means is that if x is 3, then the whole function will be undefined. Now look at something. When you put 3 here, you are going to have 3x minus 1 over 3 minus 3. 3 minus 3 will give us 0. So this whole function here will be undefined. Thank you for watching this video and all the videos under relation, mapping, and functions.